Hello everyone, welcome back. So in this video, we are going to understand a very important question. It's a least easy, but it's a tricky question, has been asked in many interviews question. Okay, so don't take it lightly because you will understand a concept here and that will help you in the most product-based companies. Okay, so let's understand again. Okay, so the question what we have given the nums we have given, right? And it is saying an index I means what? An element at index I. Let's suppose we'll call this is an element. Can we say that element is what? 4. So if this is an array, let me write again here. 2 we have, 4 we have, 1 we have, 1 we have, 6 we have, and another is we have 5. So index is what? Index will become what? We can say index is 0, 1, 2, 3, 4, and 5. So how many element is there? Nums. This is your nothing but nums, right? And this nums have size what? 6. That is why index start from where? Index I start from where? 0, 1, 2, 3, 4, 5. Can we say that? We can say that, right? So any element. So an element, let's suppose we call this element. Give 1 second. So let's call this element is nothing but this 4. So if an element, let's call 4, is at index where? At 1. So index I, if I is 1, right? If an element at index I will be a part of hill if its nearest non-equal neighbors, means its neighbor will be what? In the left side is 2 and the right side is 1. Are they equal? Right? They are non-equal. Its nearest non-equal neighbors, right? Left and right, both are smaller. If both are smaller, means it will be a part of hill. Oh, the 4. So can we say that if I write nums at what? Nums at I minus 1. Who is I minus 1? If this is at I, then I minus 1 is what? This one, right? Is it less than nums at what? Nums at I. Yes, it is smaller. Can we say that nums at I plus 1 is less than what? Nums at I. Yes. So if these two conditions met, means both are smaller, right, than the element at index I. Understand? If the element at I is greater than left element and greater than right element, so can we say that the nums at I should be always greater than nums at I minus 1 and greater than, right? Greater than what? Nums at I plus 1. So this is the first thing that we have to understand from the first line. So it is saying we have given array, nums we have given, array element we have given in those nums, and any element at index I will be a part of part of hill if the nearest element in, we can say, left side and right side both are smaller. If both are smaller, means this can be a part of who? This I, this element 4 can be part of the hill. Understand? I hope you understand. Can I clean it? Let me clean it. So this is the first concept that we have given. Let's read further. Now it is saying similarly an integer I having index, we can say, is a part of value if the closest non-equal neighbors of I are larger than this. It means, you know, the who will be the part of what you call hill, right? When we call about the value, means an element is a part element of this what you call array. An element of this array will be a part of value if its nearest non-equal neighbors left and right both are larger. So if we'll take, let's suppose again we'll take what, 2, 4, 1, 1, 6 and 5. This was our array, right? This was our array. 0, 1, 2, 3, 4, 5. This is nothing but nums. Can we say that? So second line, it is saying any element will be a part of value if its nearest non-equal neighbors left and right both are larger. So let's suppose, for example, for this example we can take this one. Let's suppose this one. Okay, but no, we don't. We can say, yeah, for now consider that. Okay, the neighbors we have is greater than. Okay, so if we'll say we can take, let's suppose, just change a value. I'll take 3 here. We'll discuss this more, how we'll implement this one. Just for understanding, I'm saying just change this value, right? So for this element, when we are talking about the 1, so if the element nums at I, what is nums? This is 2. So nums at I is less than nums at left index, means the previous index, correct? So this is correct. 4 is greater than 1 and nums at 1 is less than what? Nums at 3. We can say nums at I plus 1. So this is another concept. The very first concept was where when the nums at I is greater than nums at what? I minus 1, and it was less than nums at I plus 1. No, this was greater. What I'm doing here? Greater than. Okay, it means this will be less than, right? These two elements are smaller, right? And this is the smaller, right? This will be greater and this will be a smaller. In childhood we used to understand, right? Either no, udhar choke, means this is small one, right? This is a smaller one, right? And this is bigger one, remember? So this side is smaller, this is smaller, this is smaller, but this is bigger, this is bigger. Understand? So when the first condition met, it become what? It become a part of hill. This is for hill. And this become what? When it's a part of valley. Two things, understand? When the current index is smaller, greater than both sides, left and right, it's a hill. When the current index is smaller than left and right, it means it's a valley. So this was the given statement we have. I hope till now you have understood, right? Then we are given what? Adjacent index I and j are part of same hill or valley, right? Either it will be same hill, part of same hill and same valley. And so nums at I is nums at j for this condition. So if this was what? So we have given 2, 4, 1, 1, 6, 5, right? So can I say that this was what? 4 was greater than left and greater than right, means it was what? It was hill or a valley. This was hill, right? So this is our hill, correct? But the statement further saying that adjacent index I and j are a part of same hill or valley if the nums at I is equal to nums at j. So this is a part of, from here to here is a part of what? Hill. Can we say that? Give me 1 second, guys. So I'm saying from here to here, it's a part of what? It's a part of hill. Can we say that? And so if we are going to check these two value indexes, right? Means one, we will check two, one is already part of hill, then we'll say one. Okay, so this one, it will check first with this one, right? So nums at I and nums at j, let's suppose this is nums at I, nums at j. If both are same, so this will also become part of hill. Can we say that? You can say that, right? Also it is saying that it's a part of hill or valley. So third condition is that. Okay, now it is saying that note that an index I, an index will be a part of hill or valley, right? It must have a non-equal neighbors on both left and right of the index. Okay, means we will skip equal elements while comparing if they don't count as a peak or dip alone. I hope you understand, right? And then finally we'll return the number of hills and valley in the sum, in the num, right? So let's understand, and then we'll go through the approach. Okay, so let's understand this example and try to understand the output, how output coming 3. Okay, so very first, what we have given, let's see the nums we have given is like this: 2 4 1 1 6 5. Can we say that this we have given? Okay, this is the num we have given. So if this is the element, right, and the index is what? 0 1 2 3 and 4 5. This is the indices, right? Now once this is done, let's understand here. So let's look at nums at 4 first. Okay, when nums at 1 we have, nums at 1 is what? 4. Can we say that? Means its left is what? Nums at 0. So when we say nums at 1, nums at 1 is 4. So what is it? Left neighbor? Left neighbor is what? Nums at 0, and it is what? 2. Right neighbor is what? Nums at 2, and its value is 1. Right? Means we are talking about like this: 2, 4, and 1. Let's suppose segregate this just for understanding. So these 3 are, let's suppose, a kind of hill, either it's hill or mountain. Yeah, hill or valley. Okay, so if we consider this one, means this is smaller, this is smaller. So if we'll represent in the graph, let's suppose I'll go with this one. Okay, so in the graph, if we represent, can we say this is your 0 0, right? This is your 2 1 2 3 and 4. Can we say that? Similarly, 0 1 2 3 and 4, and so on. This is your y. So if we will represent, what? 0 1 2 3, and we will represent what? 0 1 2 3, and we'll take one more, 4. So if we are representing these 2 at here, okay, at this point, so it will go till where? Till here, right? So this is the height of the first hill. Okay, or if you want to see like a hill, you can say this is your hill. Then we have 4, right? So at index 1 we are getting, let's suppose, wrong place I've taken. Give me 1 second, guys. Okay, so if we will represent, give me 1 second. Okay, so at 0, but what we have? We have 2, we have, right? So if we will represent this, it will go till here. Okay, then we'll at 4, will at 1 we will go what? At till 4 we will go till here, it will go, right? And then at 2 we'll go what? at 1 means still here. Now you can say that you understand, right? I mean, it's a kind of, can we say that it's a kind of like this, right? This type of hill we have given. Can we say that? And so we can say here that since this 4 is greater than 2 and this 4 is greater than 1, means this condition satisfied. Either you understand through the graph or you understand through this value, right? Means this value is bigger than this value and this value, and that is why we can say this is a hill. Yes, this is a hill. This is not valley. Valley will become 1 when it will come like this. So this will become valley. This will become what? Hill. So that we have to understand. Okay. So can we say that when nums at 1, what we have found? This is a valley. Understand? Now let's understand nums at. Let's understand nums at 2. Okay. So when nums at 2, what we are getting? We are getting 1. We are talking about this element. Okay. So nums at 2 is 1. Let's take nums at 3. What? Nums at 3 is 1. So both are equal. Remember, means when this nums at I is equal to nums at j. If this condition nums at I and nums at j will match, right? Means both are equal. This is equal. So when it is equal, we skip forward. Understand? To the next non-equal, that is what we have, nums at 4. So this is also equal. So it will not go here, it will move to here at 6. And so because here now we will move to here, right? What you call at 6 we have here, right? So the left will become what? At nums at 1, which is 4, right? Which is 4. And right will become what? Right is also non-equal, and that is nums at where? At 4. So we'll skip these two. We'll skip. Will not do anything. Okay. Means we have, sorry, we have to skip this one. Okay. We are talking about this one, right? So now this nums at here we are taking out. Sorry. Correct. So we have nums at 1, that is your left, and right will be here, right? Because our current pointer is at here, right? So we will skip at 1. I hope you understand, right? Then this value is nothing but what? 6, right? So left is this, right is this. Okay. So can we say that, let me clean it. Okay. So can we say that the hills that we are currently seeing is nothing but what? Is 4, 1, 1, 6. So our current pointer at here, right? And the left is this and the right is this. Can we say that? Right? Means we will check this one. This one is greater than this one, right? Means 1 is less than 4, right? And 1 is less than 6. Both condition matches. This condition, this case, both are true. This is also true. This is also true. Means this condition matches for this left and this right. Can we say that? So at this condition, what will happen? This is true. And we'll say what? If this is both are smaller, right? 1 is less than 4. 1 is less than 6. Means this is what? This is valley. Right? So once I clean this, so can I say that now this is become what? This will become what? Valley. Nums at 1, what we were? Not valley, right? Sorry, I have written this valley. This is our hill. This is our hill, right? I surprised. I have written a hill. So this is your hill. This is your valley. Okay, that's fine. Now understand the next value what we have. Let's check the next value. Nums at, we'll check this time 4. So current pointer will move to here, right? At here. So when nums at 4 is nothing but what? We have 6. So next we will check. So 6 is greater than 1 and it is less than what? 5. No, sorry. It is greater than this also, right? In both sides. So this is bigger than both. Means this become what? Let me clean it first. Doesn't looks good. Okay, so this 6 is greater than left and greater than right. It means this is hill. So we can say this is also become what? Hill. This is also hill. Understand? So we reach to the last. So we'll skip this one and the first we have already skipped it. Okay. So can we say that how many hills and valley we have? 1, 2, 3. Total count is 3. So hills at index 1 we found, hills at 4 we found, this hills, valley we found what? At 2. So total is, we can say, if we will represent in here, so we can say here is hill, we found at hill here, this is also hill, and this is at where? At here, this first, right? This valley, this was valley, right? Like that we can say, if we'll represent, this is hill, valley, hill. Like this we will say that, okay? And you will provide the index, okay? I hope you understand, right? So now understand what is our intuition, okay? So our intuition, like our goal is to count how many times a number is at peak, that is hill, or what you call valley, right? So we have to count how many times a number, that is nums at what? Element. Nums at this element is a hill or a valley, hill or valley, right? So we have to count the given numbers in the array, right? Is at peak, at hill, or at dip, that is valley. But we can't just compare direct neighbors, right? We will not count, we'll go and we'll keep comparing that, right? Because if duplicates value happen, right, like this, if duplicate value we have, let's suppose 1 1. So don't break the landform. We will not break the landform that we have seen, right? They are a part of the same hill, right, or valley. If it is hill, it was hill, it will be a part of him. It will be a part of what? Hills or valley. Like this we have hill, it is a part of hill. If this is a valley, this will be part of valley. I hope you understand, right? And a hill or valley exists when both left and right are non-equal. It's non-equal, right? Non-equal, as you can see here, and point up or down accordingly, either hill or valley, right? So for if we are talking about this example, right, what will happen? Let's understand another example. So let's try to understand another example. It's very important. We have 3. We can take 3. We can take 4. We can take 4. Okay. Why I'm explaining with why I'm explaining the intuition with this example, you will understand in 1 or 2 minutes. Okay. So keep focus. Just think that you have given the nums is this. Okay. So index will become what? Index will become 0, 1, 2, 3, 4, 5, 6. These are the indexes. So we have how many elements we have? 7 element we have, right? In this 7 element we have. Okay. So we reduce it to the important shape. Let's do the by removing the duplicate consecutive elements. So if we will remove what what do you call consecutive, right? The consecutive duplicates. Can we say that? It will remove the consecutive duplicates. What are the consecutive duplicates we have? 3, 3, then 4, 4, then 2, 2, right? If we'll remove this, the new simplified, what? Simplified. If we'll do the simplification of this array by removing the duplicate one. This is 3, this is 4, this is 2, this is 1. And we say that this is our simplified nums, or you can say array, or simplified nums, we can say that, right? Now look at let's call a 4, right? So 4 is greater than 3 and 4 is less than 2. It's true. This is true, right? Then let's go with here 2. So 2 is less than 4 and less than, and what do you call, 2 is not less than 1. Okay, so we can say it, yeah, it is greater than 1, we can say, right? So if, for example, we will not take 1, we'll take some other value. Let's suppose let's take 7. So this here is 7, so this here is 7, right? Just change in the example because we want to understand the concept. Okay, here what we have is 2 is less than 7, so this will become your hill, right? And this will become your valley. Just made a change, right? It's fine. We have to understand the example. So once you will remove the duplicate, right, we only care about the shape formed by changing the value. That is this. What we care about, the we care about the shape formed by the changing value, and these are the shapes, either hill or valley. So can I say that very first my approach will be, let's clean the array. Can I say that? Once we will clean this, we'll get the simplified one, right? Then we will traverse from I where 1 to n minus 2 till the last, we can say. Okay, we'll go like this. Why we are traversing from I equal to 1 to n minus 2? Think, we want to ignore the first you can say element, which is at where, at 1, and the last element. So they, since they can't have both left and right neighbors, because there is no left here, right? We don't have left here and we don't have right here, and that is why we have to ignore the first and the last, right? Because they don't have left and right, they can't have, right? So for each index I, that will start at from where, at 1, right? What we need to check, we'll check what, let's suppose call array or nums. We have nums here, write the nums itself. So nums at I is greater than what, nums at I minus 1, that is left, and it is greater than nums at I plus 1. Means this is your, in the case of hill, right? Very first we can say the point, this is point A. Point B, if nums at I is less than nums at I minus 1, and it is also less than nums at I plus 1. This will be the case of value. So now just we need in the third step, right? In the third step, first step done, second step done, and this is third step, right? So what we need to do, just think, just count. So can I say that we just need to increment the count each time, and you will find the hills or valley, right? And you will return the count. Okay. So let's understand the code, right? So very first we have given nums we have given. So we'll create a list of cleaned what do you call elements in the list. So we'll first add the nums at 0, right? And we'll remove the consecutive duplicates. Very first we'll add the nums at 0 in the cleaned one. Okay, means first element will add into the clean one. Okay, then we'll remove the element from I equal to 1 to the last element. Okay, and then we'll check if nums at I is the consecutive element is duplicate. Just add the nums at I. Will not do anything, just keep adding into the nums at I. Okay, in the clean list, right? This is a list. I hope you understand the list and array list, linked list, these things, you know, basic in the Java. Okay, if you don't know, let me know in the comment section. I'll create another video to make you understood. Okay, then you just need to create what, another loop, and we'll check hills and valley. You will check the previous, means left, current, and next, right? So previous is your previous is neighbor, previous neighbor is previous hill, and the next hill. You will keep checking all the values. How? If it is greater than both, current is greater than both, right? And if it is less than both, means the case of hill and the case of valley, either this is hill or valley, in both case count, we will increase the counter and will return the counter. So that's all we have in this video. I hope you understand, and let me know in the comment section that you have understood or not, right? And thank you for liking the study videos, and I'll appreciate your time to watch the video. If you still have any doubt, if not understanding the problem statement, if not understanding the code, let me know in the comment section, then only I can create a better videos for you. If you have any doubt, please let me know so I can create a better videos for you. And thank you for liking a study video. Keep liking, supporting ExpertFunda so I can create better videos for you. Thank you guys. Thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.